Welcome and study with Tanzania Institute of Education.
Welcome Form 6 student to our beloved subject chemistry. My name is Madam Catherine Shirima. Today I prepared some questions to you from the topic of inorganic chemistry, but in subtopic transition element. So get it prepared, take your pen and your paper so that we can solve together the questions, or we can discuss together the questions. One of the topic I said, these questions need to extract idea from transition element. Transition element. My first question is, are copper and zinc transition element? This is the first question. Question number 1. Are copper and zinc transition elements? This is our first question. How can you answer this question? Okay, let us discuss together. You know what? These questions need to extract idea from transition element. What do you remember about the transition elements? Before defining what is transition elements, let us extract idea from modern periodic table. As you remember, the modern periodic table consists of 4 blocks, which are S, P, D, and F. We have 4 blocks. There are 4 blocks. There are 4 blocks in modern periodic table. Modern periodic table, which are S, P, D, and F. In these blocks, the elements are arranged according to their electronic configuration. That means when the last electron filled in S orbital, that means the elements belong to S block. The same applies to P, D, or F, that when the last electron are filled in P, D, or F, then the elements belongs to P, D, or F respectively. Therefore, let us come to our question. Our question says that, are copper and zinc transition element? Where is transition element in the modern periodic table? As I said that the modern periodic table consists of 4 blocks. The transition elements are found in D block. Transition elements are found in D block. Transition elements are found in D block. But by definition, when you say transition elements, are elements with partially filled D orbital. By definition, transition elements are elements with partially filled D orbital. These have partially filled D orbital. What does it mean when I say partially filled d orbital? This means that for the element to be called the transition element, it must have at least one electron in d orbital or form ions which has at least 1 to 9 electrons. So that is the definition of transition element. But when you refer the d block elements and look the placement of copper and zinc, the d block elements consist of 4 series. The first series is where you can find the copper and the zinc. First series. This first series consists of 10 elements from scandium to zinc. Let us see the electronic configuration of these elements from scandium with atomic number of 21 to zinc with atomic number of 30. We're going to see their electronic configuration, which will enable you to know or to understand if copper and zinc are transition elements or not. Okay, let us go in together. Let me draw the electronic configuration of the first series element in D block. Electronic configuration. Start with element. Its symbol. Okay, element, symbol, atomic number, its electronic configuration, okay, let us see this table. To start, I said that we have scandium, which has electronic, which has a atomic number of 21. Scandium, starting with scandium. Scandium, its symbol is Sc. Followed with titanium. We have scandium, titanium, vanadium. Titanium has the symbol of Ti. Vanadium, V. From vanadium, then we have chromium. Then from chromium, we have manganese. From manganese, we have iron. From iron, there is cobalt. From cobalt, there is nickel. Then from nickel, there is copper. Then the final one is zinc. So as you can see, from scandium, scandium has atomic number of 21, followed with titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, and zinc 30. So the first series of the D block element are 10, and the atomic number is as you can see. Now let us see their electronic configuration. I think you are familiar of how to write electronic configuration. Starting with scandium, the electronic, because atomic number is 21, that means it has got 21 electrons. So to write electronic configuration, we are starting with square bracket A, R, followed with 3D1, 4S2. This means that when you're writing electronic configuration, if electronic configuration is so long, it is allowed to use noble gas elements. As you know, noble gas, we have neon, we have argon, and krypton, and xenon. So you have to use the noble gas which is near to to electronic configuration. For example, scandium has 21 electrons. So therefore, this argon, it has 18 electrons. So we can write argon followed with 3D1, that is argon 18 electron, D1, that means 1 electron in D, 19. Then 4S2, 2 electrons from S, this form 21 electrons. Followed with other elements like titanium. Now we're going to write square bracket argon 3D2, 4S2. That means 18, 20, 22. Vanadium, argon 3D3, 4S2. That means 18 electrons plus 3 plus 2, it is 23. Followed with chromium, which is argon 3D4, 4S2. But here in argon, I'm going to tell you the reason here we are supposed to write 3D5 and 4S1. We're going to see the reason. Then manganese, which is argon 3D5, 4S2. Iron, argon 3D6, 4S2. Cobalt, argon 3D7, 4S2. Nickel, argon 3D8, 4S2. Then for copper, it is argon 3D. It is supposed to be 3D9, 4S2. But again, it is not written like this. Instead, you are going to write 3D10 and 4S1. Also, there is a reason. Final is zinc, which we are going to write argon 3D10, 4S2. So, as you can see, this electronic configuration of the first series of D block elements, which are transition elements. When we refer our question, the question says that a zinc and copper transition element. We can see placement of zinc and copper here is copper, and zinc is here. Their electronic configuration, we have seen for copper, the electronic configuration is argon 3d10 4s1. And for zinc, electronic configuration is argon 3d10 4s2. So are these transition elements? Okay, let us recall the definition of transition element. I said transition elements are elements with a partially filled d orbital. That means the d orbital must be incomplete. And I said that the d orbital must contain at least one electron, or those elements can form ions which has at least 1 to 9 electrons. As you can see this, starting with copper. Copper, its electronic configuration is argon 3d10 4s1. It is d orbital, it is fulfilled. So you can see that maybe copper do not meet or not qualified to be called a transition element. But let us see the chemists behind. Copper form compounds in which it exists in 2 ions, which are copper 1 and copper 2. So we have copper 1 and copper 2. When you look this electronic configuration, it is configuration of copper at neutral state. This is what is electronic configuration of copper when it is neutral state, neutral element. But after forming ion, let's say after lose 1 electron and become copper 1, it is electronic configuration now. We can see it is written as argon 3d10 4s0. Why 4s0? It is because this copper has already lose 1 electron and become copper ion. Therefore, it is 1 electron, from S, it is not there. It is now 0. So therefore, the copper 1, the actual electronic structure is argon 3d10. So you can see copper 1 do not qualify to be called transition because the d orbital, it is fulfilled. But when you come to copper 2, that means during the formation of compound, also there is copper 2. So here, in the electronic configuration of copper 2 can be written as argon 3d9 4s0. That means when we say copper 2 ion, that means 2 electrons lost, 1 from S and 1 from d orbital. Now the d orbital contains 9 electrons. So if you try to check this electronic configuration of copper 2 ion, it seems that the d orbital has 9 electrons, which qualify the definition of transition element. So therefore, we can conclude to say that copper is transition element by looking the electronic configuration of copper 2. As I said, copper exists in 2 ions. We have copper 1 and copper 2. So therefore, copper is transition element. However, when it is in electronic structure in a neutral state, it is d orbital, it is fulfilled. But for copper 2, the d orbital contains 9 electrons, which is partially filled. So copper is transition element. I think we are together, students. Another question, also I ask you about zinc, as the question says that is zinc and copper transition element? So let us come to see about zinc. How about zinc? When you come to zinc, its electronic configuration is argon 3d10 4s2. If you try to check this electronic configuration of zinc in its neutral, when it is neutral element, you can see that d orbital is fulfilled. Because the d orbital is fulfilled, it is not qualified to be called transition element. But when you come to see in the chemical reaction, zinc form compounds which exhibit only one oxidation state. Zinc form compounds in which it exists in only one oxidation state, which is 2. Therefore, we have zinc 2 ion, that when it forms compounds, it exists, or it forms ions which exists in only one oxidation state, which is 2. So we have only zinc 2 ion. When you try to write the electronic configuration of zinc 2 ion, it will be like argon 3d10 4s0. That means here no 2 electrons in S, because when you see positive in chemistry, it means something which is lost. So zinc lose its 2 electron. This will be removed from S. Now the configuration which remain is argon 3d10. When we come to the definition of transition elements, as I said that transition elements must contain partially filled d orbital. But if you try to check, the d orbital in zinc is full filled. This is full filled. Therefore, according to the definition of transition element, zinc do not qualify to be called the transition element. I think you are together, class. Okay, another question. We have already finished about question number 1. Okay, let us see about question number 2. The question number 2 says that there is an expected electronic configuration for elements chromium and copper. What caused this? There is an expected electronic configuration for elements chromium and copper. What caused this? Again, let us see the electronic configuration of the first series of elements in D block. You can see chromium. Chromium, its electronic configuration is written as argon 3d5 and 4s1. But when you come to copper, it is written as argon 3d10 4s1. You can ask yourself, what caused these elements to have unexpected electronic configuration, and what is expected one? In reality, if you try to check this series, you will notice that the expected electronic configuration for chromium, let us check about chromium, was supposed to be argon 3d4 4s2. Of course, here the number of electrons are still 24, because chromium, its atomic number is 24, the number of electrons are 24. So therefore, because it is 24, but if you try to check here, it is 3d4 4s2. But according to this table, it is written as argon 3d5 and 4s1. According to the table, is written as argon 3d5 4s1. Same applies to copper. The expected configuration was, for copper, it is supposed to be argon 3d9 4s2. But according to this table, the unexpected configuration is written as argon 3d10 4s1. There are changes. If you try to check for chromium, it is from 3d4 to 3d5, and here d9 to 3d10. What caused this? Normally, the reason is due to extra stability of half-filled and full-filled of their d orbitals. The reason here is due to extra stability. This is due to extra stability of half-filled and full-filled of their d orbitals. How is this? Normally, when you refer the general chemistry, the rules of assigning electrons in atomic orbital, we have one rule which is said half-filled rule and full-filled rule. This is applied to p, d, and f orbitals. Normally, for the p orbital to be half-filled, it must contain 3 electrons, full-filled 6 electrons. And for d orbital, the half-filled must contain 5 electrons and full-filled must contain 10 electrons. And for f orbital, the half-filled must contain 7 electrons and full-filled must contain 14 electrons. But we are dealing with d orbital. If you try to look chromium and copper, the d orbital, which is 4, it is less stable as compared to d orbital with 5 electrons. As I said, the reason is due to extra stability of half-filled. Therefore, chromium, the half-filled d orbital which contains 5 electrons, this one, is more stable than the d orbital with 4 electrons. So reason there is due to extra stability of half-filled d orbital. So d5 electrons is stable than d4 electrons. That is for the case of chromium. When you come to copper, the expected is argon 3d9 4s2, and unexpected one, as according to this table, it is 3d10 and 4s1. Reason behind is the full-filled rule. As I said that for d orbital to be stable, it must have at least 5 electrons which make it to be stable, or 10 electrons which make it to be stable. So according to here, because the 3D, there are 9 electrons, 1 electron must be removed from S to D to make it 9. So that the electronic configuration can be 3D, 10, and 4s1. Therefore, 3D 10 electron is stable than 3d9 electron. So there, the reason which I said that is due to the rule of half field for the chromium and full field for copper, as the rule which is used to assign electron to atomic orbital is the one which change the electronic configuration of chromium and copper from the expected one which is this one to this stable electronic configuration. So this is stable configuration. This is stable configuration. To what? And for the copper, change from the expected one, which is this one, which is unstable configuration. This is unstable configuration, into this configuration which is stable. So this is stable configuration. Stable configuration. Also, this is unstable configuration. Thank you very much for listening. I hope that you have enjoyed enough. But I have some more questions to you. Question number 1 is, although scandium belongs to D block elements of the periodic table, but it is not transition element. And question number 2 is, explain the fact that all transition elements are D block elements, but not all D block elements are transition elements. You are with me, Madam Catherine Shirima. Let me say bye-bye.